Good morning to all. I am Dr. Jay Shankar, Professor Department of ECE. Today we are going to see mesh analysis, which is used to calculate current flowing through a circuit using Cramer's rule. So basically we are having two things. One is called Kirchhoff's voltage law and Kirchhoff's current law. And then using these laws we have two analyses. One is called mesh analysis, another one is called nodal analysis. So mesh analysis is used for calculation of current and nodal analysis is used to calculate voltages. So there is a rule called Cramer's rule, which uses basically Cramer's rule is used to calculate current flowing through a circuit using analysis. Suppose I have a matrix, so I am writing it as a R11, R12, R1 and R21, R22 followed by R31, R32, R33. This is a 3 cross 3 matrix which consists of 3 loops followed by my unknown value I1, I2 and I3, and then my voltage sources are E1, E2 and then E3. Now using Cramer's rule, what I can do is I can calculate the determinant of this R matrix, which will give me del value, and del 1, del 2, del 3 are calculated by replacing this first column of resistance matrix by voltage source. So I'll get del 1. Likewise, second column is replaced with voltage sources, then it is called del 2. Third column is replaced, it is called del 3. Finally, my I1 will be del 1 by del, I2 will be del 2 by del, and I3 is del 3 by del. Let us go for a problem. We are considering a circuit with 3 loops and then 2 voltage sources. So we have a circuit. The value of this resistor is 2 ohm and this resistor is 6 ohm and third resistor is 2 ohm, and the distance between 1 and 2 is 4 ohms, and here the common resistance is 5 ohm, and this voltage source is 25 volt, and here I have a source which is 10 volts. Now I need to consider 3 loops are there. I1 is flowing through the first loop, I2 is flowing through this second loop, and current I3 is flowing through this third loop. Now we form equations using Kirchhoff's law. So as KVL says, I need to write current flowing through this first loop is so I am going to write 2I1 plus 4 into I1 minus I2, because if you consider first loop, current I1 is flowing through this way, I2 is flowing in this direction. When you see from the first loop, the I2 is negative voltage, negative current, so I am writing 4 into I1 minus I2, that will be equal to 25, because now I am considering this current is entering into negative terminal. This is my first equation. Then I am following my second loop. My second loop says that 6I2, so I2 is flowing through the 6 ohm plus 5 into I2 minus I3, the current, the resistor which is common to second and third loop is 5. So 5 into I2 minus I3 plus again I have to write 4 into I2 minus I1. There is no voltage source in second loop, so I am putting it as 0. I am going for my third loop. My third loop says that 2I3 plus I have a 5 ohm resistor, and then this is called I3 minus I2. That will be equal to minus 10 because here my current is entering into positive terminal, so I am considering it as a negative voltage. Now what we are going to do is we have to frame Cramer's rule. To apply Cramer's rule, I need to form an equation. That equation says that matrix is minus 4 0, minus 4 15, minus 5 followed by 0, minus 5 7. This is my R matrix followed by my unknowns are current, so I am writing I1, I2, I3. That will be equal to 25, and this is 0, this is minus 10. Now what we are going to do is, already we have discussed, so I am calculating del. So del value is 368, so that is nothing but the matrix which is 6 minus 4 0, minus 4 15, minus 5 0, minus 5 7. That is my del value. Likewise I am calculating del 1 by replacing first column with 0, minus 10, and then my second column is minus 4 15, minus 5. My third column is 0, minus 5 7. So if you calculate the determinant of this value, that will give you 1800. Likewise I am calculating del 2. So del 2 value is 400 and del 3 value is minus 240. When you are getting minus 240, that means my assumption of I3 current is in opposite direction. Then I am calculating my first loop current, which is I1 equal to del 1 by del 2. So which will be around 4.89 amps. Likewise I am calculating I2 value. My I2 value is del 2 by del, which is equal to, again if you are dividing this value, you are getting 1.08 amps. Likewise my I3 value is del 3 by del, that gives you minus 0.65 amps. Then we have branch currents are also required, so we are going to calculate I1 minus I2, which is common resistance is from I1 and I2. I2 minus I3 is the common resistance, which is 5 ohms between I2 and I3. So these two values will give you I1 minus I2, means you will get 3.81 amps, that is current flowing through that particular branch, and then here it is 1.73 amps. This is I2 minus I3. So now we are having all the branches. The branch currents are calculated using mesh analysis. If you go for nodal analysis, then you have to use, if you are using nodal analysis, you have to apply Kirchhoff's current law. So you have to calculate I equal to V by R. This should be followed, and any current source, any voltage source with a series resistance can be converted to a current source with parallel resistance. This method is called source transformation. So source transformation is nothing but any current source can be converted to voltage source, or voltage source can also be converted to current source. So this I is nothing but V by R. Likewise, mesh analysis can be calculated even for calculating nodal analysis. So there are two things, one is mesh, Another one is node analysis. So vice versa, you can convert node to mesh or mesh to node using V equal to Ri concept. Thank you for patient listening.